In this lesson, we're going to continue our discussion of inventory management. So far, we've only discussed policies for a single item at a single location. And so all the models we've developed so far, from EOQ to single period to base stock to continuous and periodic review, have all been about a single item. And they're not really realistic, but consider all these models building blocks. We're building up to model a more realistic situation. So in this lesson, we're going to look at how to handle multiple items, and then also look at the impact of having more than one location for storing inventory. So the agenda, first we're going to look at the idea of multiple items, and we're going to do this in two pieces. First we'll look at ways to group like items to save management time, and how can I put different SKUs together and treat them the same. Then we're going to look at exchange curves, and this is where I can make trade-offs between, say, a budget constraint or some kind of overarching constraint and the individual SKUs that I have to manage. Then we'll spend some time and look at an example, a case study, where about location pooling, and this is the inventory policies where I have multiple locations or a single location. So let's get into the multiple items first. So the only change to the assumptions we're going to make is down here, the number of items. We're going to change from looking at one to many. How do I handle policies when I've got hundreds or thousands of SKUs that I'm managing? So when we think about it, first we have to ask the question, why do we even care? Why can't I just do everything independent? I know how to do an EOQ for each item, and that will be optimal by itself. But there's a couple problems with doing that. One is, if I do all of the individual SKUs by themselves and I have thousands of them, I'll have totally discoordinated ordering. I'll be ordering stuff all the time because my T-stars will be 3.6 days and 7.8 days, and they'll all be all over the place. So there'll be a lack of any coordination. But then also, by doing them individually, I can't take into account any common constraints. Think of a budget. Everything we've done so far assumes that companies have unlimited capital to have as much inventory as they need to meet that level of service. That's never the case. You're always going to have some kind of budget. But if I only look at the models independently, how am I going to be able to figure that out? So you have to have some way of making a trade-off, and we'll get into that. Then there's ideas, if I look at them independently, I'm going to miss some opportunities for consolidation. Because if I order things very, scattershot, as opposed to bringing them together and consolidating them, maybe when I consolidate them, I can save some money. I can have some shared costs. And then the last, and probably most important, is it's a waste of management time. If I do everything independently, I'm spending all my time managing these things independently. And management time, your time, is the scarcest resource. So by finding ways where I can treat sets of SKUs together and treat them commonly with the same operating policies, that'll save me a lot of time. And that's what's really important, because as I said, management time, your time when you're on your job, is the most important and the scarcest resource. So two issues we're going to solve in this lesson. First, we're going to look at aggregating SKUs, and we're going to look at this in two ways. There are many other ways. The first, we're going to look at common cost characteristics and develop some breakpoints. And then we're going to use the old power of two policies that we introduced several lessons back. Then we're going to look at these what are called exchange curves, where we can make trade-offs between some kind of budget for either cycle stock or safety stock, and determine what that does. What does that do to my service level? All right, so let's get started.